Hello and welcome to our unit on ecology. We're going to start this unit out by talking about energy. Energy is important in ecology because energy flows through ecosystems, and it's an important part of it. Organisms and their environments constantly influence each other and are constantly interacting, and there are some terms that we need to learn before we can really talk about these things. First term, and I know you've heard these terms before, abiotic factors. Here are some abiotic factors. Can you guess what abiotic factors are? Well, bio meaning life, a meaning not life, so they are things that are not living, factors that are not biological. Sunlight, water, wind, soil, those kinds of things are abiotic factors. Here's some pictures of some biotic factors. Obviously, if abiotic factors are non-living, the biotic factors are the living elements. And that would be here, the organisms. Here are examples of, even though they're small, bacteria are organisms as well. So all different kinds of organisms. So then how does energy pass through an ecosystem? Well, before we talk about that, let's actually define some of these things. What is an ecosystem? An ecosystem, when we talk about that, we are just referring to a community of organisms plus their environment. Well, remember way back in one of our very beginning units last semester, we talked about what is a community. Well, let's define that. What is a community? Community, if you remember, is different populations, multiple populations. Well, do you remember what our definition of population was? Not just the people that live in town or something. It's the biological definition for population. I'm abbreviating these definitions, but a population is just one species of organisms, a group of that one species that live in the same place at the same time. So if we kind of work backwards, here we have our population is one species in a particular area. A community would be multiple species, multiple populations in that area. And the ecosystem is the community plus its environment. Now let's look at another word here that you may or may not be familiar with, biome. Probably all dealt with this word at some point. What is the definition of that? The biome is a very large community of organisms occupying a major habitat. So I just used another word that maybe we need to define, right? Habitat. We're going to actually look at biomes in a later section in this unit and talk about a lot of specific biomes, but it's a very large community occupying a major habitat. So then, what's a habitat? A habitat is just the natural environment of an organism, and that's what a habitat means. So we have a couple other, a few more words here that we need to address. One, the biosphere, and you should remember the biosphere from, again, our earlier system. The biosphere is the part of the earth occupied by living organisms. The surface, the atmosphere, the hydrosphere, wherever around on the earth that has life, that is part of the biosphere. So I wrote that down for you. Also, the very last word of the day is niche. And niche is probably a lot like what you think it might be. It's the particular combination of resources that a species is adapted to exploit. That is their niche. It is whatever resources they are. They could be biotic or abiotic, combination of both. It's the resources that species uses, and that's what a niche is. And I hope you can notice that we talked about biotic factors and abiotic factors. If you look at some of these different ideas, some of them involve biotic factors, some involve abiotic factors, some involve both. And we're going to work on that a little bit in class with your abiotic and biotic activity. So let's move on and look at a few more terms that we're going to need to know. Here are just some pictures. Give you a very visual idea. If I draw a line down the middle and separate those on this side, I have autotrophs. Wow, what are autotrophs? It looks like they are all organisms that make their own food. Auto, self-feeding. These are all heterotrophs. They get their food from eating either autotrophs or other heterotrophs. They do not make their own food, right? None of these organisms photosynthesize. Now let's put some of these ideas together. Here I just put up a picture of a food web. Food webs can get very complicated. I'm sure you've all dealt with food webs in school before, and they are a way to show and demonstrate how the energy flows through an ecosystem. And let's just use some of these terms that you should know by now. You all know herbivores are animals that consume plants or algae. Carnivores are animals that eat other animals, meat eaters. We just talked about heterotrophs and autotrophs. Here's some more terms, producers, consumers, decomposers. Well, a producer is simply an autotroph. Autotrophs they make their own food, and they're considered the producers. The consumers are the heterotrophs. They need to either eat autotrophs or other heterotrophs, right? So those are other terms that mean the same things as heterotroph and autotroph. So on land, in terrestrial ecosystems, the producers generally are plants. In aquatic systems, aquatic environments, the primary producers are generally algae. Decomposers here are organisms that break down and digest much more complex organic compounds like cellulose. Earthworms would be an example of a terrestrial decomposer. Here we also have two more terms, primary or secondary. We can have tertiary consumers. And let's take a quick look at that. If we have here in this terrestrial system, we have plants as being the producers, the autotrophs. What is then the primary consumer? These organisms that are using the energy from the producers, these are the primary consumers. A secondary, let's look at one primary consumer. We can then look at a secondary consumer right here. This fox uses the energy from the rabbit, and he's a secondary consumer. Can you find a tertiary consumer? Well, yes. If this herbivorous insect is a primary consumer and this insectivorous bird is a secondary consumer, then the hawks and owls would be a tertiary consumer in this system. So one question to think about, how do abiotic factors affect the adaptations of organisms? What are some abiotic factors that could affect adaptations of these organisms? I want you to think about that and see if you can come up with a good answer and a good explanation on your own for us in class. Here's just a food web that has decomposers on it. And one thing to point out about food webs is that the arrow always goes in the direction of the energy flow. So the energy is flowing from the sun to our producers, our plants, if we're in a terrestrial environment. We have producers when they die, decomposers get that energy, and that energy flows to the decomposers. The energy from the decomposers flows into inorganic nutrients, which flows to the producers. We have energy from producers going to consumers. Energy from the consumers going to decomposers, and the cycle continues. Now let's take a look at an energy pyramid. An energy pyramid is a way to represent the trophic structure of an ecosystem. What is a trophic structure? If you haven't heard that word before, basically when we talk about the nutritional relationships among the producers and consumers in an ecosystem, that forms its trophic structure. Each trophic level is when energy is transferred from one organism to the next in that structure. So here we have our energy pyramid with the producers at the bottom, primary consumers, secondary consumers, and tertiary consumers at the top. Now we have one important rule to mention here, the 10% rule. Basically, when we draw an energy pyramid, the idea is that each level in our energy pyramid is decreasing in size because each level is receiving about 1/10 of the energy from the level below it. So about 1/10 of the energy available here is going to these primary consumers here. So we call that the 10% rule. About 10% of the energy will be used by the next trophic level. Typically, most organisms usually use most of their energy just to metabolize, to move, or they release energy as heat, any number of things. So there's only and it varies. The 10% rule is very much an approximation. It's not a hard, fast rule, but it's just an estimate of the amount of energy that goes from one trophic level to the next. About 10% of this would be transferred to the next trophic level. So you can see that the available energy declines as we go up the pyramid. And this is also true for biomass. Biomass here is simply the total quantity of living matter at each trophic level. So, for example, the total mass of all the wolves in a forest is much less than the mass of the rabbits and the other prey, or the mass of the trees and the other plants. So just as we decrease in energy as we go up in trophic levels, the biomass also decreases. So very much related to all of this is this term productivity. Productivity is the rate at which new biomass forms. It is the very highest among the primary producers. So productivity is highest down at the bottom, and it declines steadily as you go up the pyramid and up to higher trophic levels. So an ecosystem can sustain far fewer top-level carnivores than low-level consumers and producers. Quick review. Main points. Organisms and their environment constantly influence each other. Know the difference between biotic and abiotic factors. Know the definitions of all of these different terms that talk about ecosystem, biome, biosphere, habitat, population, community, niche. Know that energy passes through an ecosystem. And because energy passes through it, the relationships between the organisms in that ecosystem, they determine the energy flow, and know what those relationships are, what the terms are for all those different organisms and trophic levels and all of that. So 10% rule, know what that means and how it applies to an energy pyramid, and look forward to seeing you in class.